So that was the demonstration of the heartbeat sensor working on a breadboard prototype. Now let's see how the LM358, the IR transmitter, and receiver work together for the detection of the heartbeat. These are the components that are used in the breadboard prototype of the heartbeat sensor. These three components are essential for the detection of the heartbeat and converting that heartbeat signal into an electrical signal through the use of the op amp and sending that electrical pulse to be presented on the red LED. So, the IR diode over here acts as a receiver of the infrared signals that are sent by the IR LED transmitter and sends those signals to the LM358 chip, which are initially low and need to be amplified and converted to electrical signals to be presented on the red LED. Within the rest period of each heartbeat, the signal received by the diode is higher as there's less blood at the fingertip to absorb the infrared waves. More infrared waves that are received by the IR diode means that there's less blood at the specific time and area of the finger to absorb those infrared waves. So the less infrared waves means that the heart is beating at that moment, which because the blood is absorbing those infrared waves, the IR diode receives less of them, and the LED will flash for every beat, which is known by a higher signal coming out of the LM358. So the next important part of the circuit is the 104 or 0.1 microfarad capacitor and the 4.7 microfarad capacitor. So the role of these two capacitors in general is to remove noise and high frequency signals. So the 104 capacitor in the circuit diagram helps with the filtering out of the noise from the power supply to the op amp to not interfere with the op amp's operations. And the 4.7 does a similar operation of filtering, but it filters for high frequency noise that might come from the amplified heartbeat signal. This leaves the low frequency heartbeat signal, which comes out of the 4.7 microfarad capacitor, and that reaches the IR diode receiver, and the signal is much cleaner as it does not interfere with the high frequency noise that might be amplified by the op amp. And this results in the signal being accurate and being presented properly on the red LED. So this whole project in its entirety focuses on the biomedical and the hardware elements of engineering. And keep in mind that, for example, the Apple Watches and other smartwatches that you wear have similar, if not the same components that are used in the circuit with the op amp and IR sensors. So getting a grasp on how these components work is actually crucial for the development of technologies that can apply to human health and our daily lives.